Okay, so today we are covering the last lesson of Unit 2. So after today, we have covered all material from Unit 2. You're going to see a quiz 2-3 on Friday. You're going to want to complete that on Friday. Its end date isn't until December 10th, but the sooner the better, if you don't want to forget this stuff or forget to do it. Remember that the quarter does end on Friday, and anything from quiz 2-2 and before will go on to quarter 1, which means its end date is Friday, and you want to make sure you have it complete before it closes. You're also going to have the Unit 2 test open to you, and of course its end date isn't until December 10th. Again, you don't want to wait too long to do it, but I do want to make sure that you're prepared for it. If you can't find the review, please let me know. I'll help you find the review. Every unit has a review and a review video that goes with it. You want to make sure that you complete that review before you take the test, because I make the review after I make the test. So it might be a good idea to do that review. Also note that once you open the test, you have to complete the test in 3 hours. You can't open the test, look at it, and come back tomorrow. It will be closed for you, and I cannot reopen it. Okay, so I'm not allowed to reopen it once it closes. If you open it and don't do it, then that's the grade that you get, and you really don't want that. So whenever you open the test, be sure that you're ready and you have the time to complete it. If you want to ask me questions about the review or anything we've done in class or any practice problems, you of course can ask me those before you open the test. I can't answer questions while you're taking it. Keep that in mind too. Okay, so there's that. Today's notes are on OMHS, and the key is there for you too. This recording will be posted there once we're done recording. Well, by 3 o'clock today at least. So today we're going to talk about proofs. Last class we did proofs with algebra, a skill that you've already learned and supposedly mastered since you are in geometry. Some of us, I think, are still working on those skills, and that's okay. Today we're going to do proofs with geometry. So they're going to look different. They're going to look maybe weird. And I will tell you that the first time you do this, it might feel hard. But you do it enough times and you do enough practice problems and you follow the little tips and tricks that I give you along the way, they're going to start to feel easier. If they aren't feeling easier, then that just means you need some more practice. And if that happens, you're welcome to reach out to me. I do have a lot of additional practice for proofs that aren't on OMHS. So if you want some help with that, just let me know. Okay. All right. So in our number 1 here, we have a given, and we learned that in a proof, they're going to have to give us a place to start, and we call that the given. And they're asking us to prove some piece of information. In this case, they're asking us to prove that 2 times the length of DE equals the length of DF. All right, and so every property we learned last class, plus all of the properties and postulates and theorems that we've learned up to this point, they're all fair game. So here's my first trick when looking at a proof. If you see a vocabulary word in the given, there it is, midpoint, there's a very good chance that we're going to have to use its definition. Also, if you see a segment that is being broken into smaller segments, there's a very good chance that you're going to need to use segment addition. Okay, so here's 2 tricks for you. Look for definitions of vocab words. And if you see a segment in pieces, you're probably going to have to use segment addition. Not always. It's not a 100% chance that you will, but there's a very good chance that you would. Okay, so step 1 in our proof says that E is the midpoint of DF. Why? How did I know that? Well, that was given to me. So we write given. Okay, well, if E is the midpoint, we know that the length of DE has to be congruent to the length of EF. That's exactly what it says here in step 2. And why did we know that? Because we know what a midpoint is. We used its definition. Now in step 3, it says DE plus DE equals DE plus EF. Look up here in step 2. It says DE equals EF. Here it is, DE equals EF. But what is different is we've added a DE to both sides. If you add the same thing to both sides, well, that's the addition property. It's just in this case, we didn't add a number, we added a segment, and that's okay. It's still the addition property. Whoa. Equality, because it's an equal sign. Okay, so now let's see. I'm going to get rid of my highlight here. Step 4 says that 2DE plus 2DE equals DE plus EF. Okay, well, I didn't do anything here to the right sides, right? They're the same. But I did go from a DE plus DE to 2DE. Think of that as like variables, right? What's x plus x? Well, x plus x is 2x. DE plus DE is 2DE. So that's just a simplifying. You could also write combine like terms. That would be the same thing. I'm going to write simplify. Simplify, combine like terms, same thing. Now in step 5, 2DE equals DE plus EF. I'm not seeing a direct correlation between 4 and 5. If that happens when you don't see maybe the relationship, look back up in your picture. It says DE, that's here, plus EF, that's here, together makes DF. Oh, that's a small segment plus small segment equals big segment. We learned that. There's your segment addition. Yay, those of you typing that in the chat box, thank you very much. And you could write segment addition postulate if you really wanted to. It's the same thing. All right, and then the very last step, step 6, says 2DE equals DF. Okay, well, I see a 2DE here, and that equals DE plus EF. And then I see DE plus EF again equals DF. This kind of looks like the law of syllogism, but we can't use the law of syllogism with this. We have to use the properties we know. We know the transitive property. The transitive property says that if A equals B and B equals C, then A equals C. Well, blue equals red and red equals green, then blue equals green in this case. So we could write transitive property. If you wanted to write substitution, that would be okay too. The transitive property is a very specific case of substitution. So if you wanted to just put substitution, that's okay. On an assessment, it wouldn't give you both. It would either say transitive or substitution, but you wouldn't be able to, you wouldn't have to choose between the two. All right, let's look at the next one. All right, in step 2, I see a given. I see the word midpoint. I'm probably going to have to use its definition at some point. I see a picture with some segments that have been broken into pieces. Potentially, I would have to use segment addition. Not always, but maybe I would. Step 1, oh, this is the exact same thing that was in the given, so we can just write given here. And I'm going to mark that in the picture. KL is congruent to LN. And then it says LM is congruent to LN. Well, LN already has just one tick mark on it. So to make LN congruent to LM, I have to give that just one tick mark also. Step 2 looks exactly like my given, but the difference is instead of segment symbols, it's lengths. And instead of congruent symbols, it's equal signs. Remember that congruent means that if the segments are congruent, their measures are equal. So if you're switching from a congruent to an equal or a segment to a length, you're using the definition of congruence. And if you need to review definition of congruence from the last set of notes, it's right there, right at the end. Okay, so now if KL is equal to LN and LN is equal to LM, well then KL equals LM, right? And we could call this the transitive property, or you could call this substitution. I'm going to call it transitive property. Is that what I did in the notes? Yeah. All right, and now the last step. We want to prove that L is the midpoint of KM. So why is L the midpoint? Well, KL is congruent to LM. We just said that right here. So if the two pieces are equal, then that means L has to be in the middle. So that's the definition of a midpoint. If you have questions, of course, you are welcome to type them there in the chat. I'm trying to do it in semi-different colors, so that way you have something to reference. So if you don't understand, you could say, I don't understand how you got the green, what you wrote in green or what you wrote in blue, and hopefully that can help me answer your question too. But if there aren't any questions, I'm going to move on to the next one. The thing about proofs is I could show you 900 of them, and the next one will still look different. So it's not a memorize every proof that she did. It's a figure out the steps that are happening. All right. Number 3, we've got a picture here. It says segment PQ is congruent to segment TQ and UQ is congruent to QS. I'm going to mark that in my picture right now before I go any further. PQ is congruent to TQ and UQ is congruent to QS. Notice I used 2 tick marks on UQ and QS and 1 tick mark on PQ and TQ. It doesn't tell me that PQ is congruent to UQ. It doesn't say that. All I know is that these two are congruent to each other and these two are congruent to each other, but it didn't tell me that they were all congruent. So just be careful with that. Of course, this is given in my proof. And then step 2, well, step 2 looks just like step 1. The only difference is instead of congruent symbols, I've got equal signs. So this is the definition of congruence. I've got all this plus sign stuff going on. Oh yeah, if you see segments that are broken into pieces, remember what to look for? Let's look for segment addition. It says PQ plus QS equals PS. Well, here's PQ, here's QS. I put them together, I get the big segment PS. Oh, this is segment addition. Double check the other one. TQ plus QU equals TQ. That's segment addition also. Okay, so one small segment plus another small segment equaling the big segment. That is segment addition. Okay, step 4. Well, these look the same and these look the same. The only thing that's different here is PQ and TQ. Oh, but up here in step 1, I know that they're equal. So I could take what PQ equals and replace it with TQ. What is it called when I take what something is equal to and replace it in the equation? Type it in the chat if you think you know. Yay, thank you, Camilla. Anyone else? Yes, thank you. It is substitution. Thank you, those of you participating. Okay, now let's look at step 5. It says TQ plus QS equals TU. Well, let's look here. TQ and TQ. QS and QU are different, but TU and TU are the same. Do I know anything about QU and QS? QU and QS are equal. It told me that right there. So this is substitution again. And I wouldn't say transitive because it's not like a logical statement where it's going this equals this and then this equals this, so therefore the first equals the last. It's just a simple what it equals I'm replacing it with. Yeah, so I would just use substitution here. That was a good question. Okay. Okay, in step 6, it says PS equals TU. Well, I know that PS equals TQ plus QS and TQ plus QS again. Oh my gosh, those are the same, which means these have to be the same. So this one, you could say substitution again, or you could say the transitive property here, either one. If you wanted to write transitive, write transitive. If you want to write substitution, that's good too. I'm going to write transitive property. All right, well, if their measures are equal, that means the segments are congruent. This is the definition of congruence again. Anytime you're going back and forth between an equal or congruent symbol and everything else is the same, you're using the definition of congruence. All right, let's look at another one. It's the day of proofs today. All right, let's see here. It says K is the midpoint of JL, M is the midpoint of LN, and JK equals MN. So we've got 3 pieces of given information. In the first step, it tells me the first 2 pieces of given information, so I'm definitely going to write given here. And I see a definition, right? Or I know I'm going to have to use the definition of midpoint because midpoint is there. Midpoint means the point is in the middle, which means that the pieces on either side of it are equal. So if I were to put that in my picture, K is the midpoint of JL. Well, these 2 pieces have to be congruent. M is the midpoint of LN. So those 2 pieces have to be congruent. And that's exactly what it says here in step 2. JK equals KL. That's exactly what I just marked. LM congruent to MN. And I just marked that also. And I marked it because I knew what a midpoint was. So this is definition of midpoint. All right. Step 3, JK equals MN. Where on earth did that come from? Oh, look. That was a given that was not written in step 1. That happens sometimes. And if you wanted to write each given on its own line, you could do that too, if you were writing one from scratch. So if you're ever looking at a proof and you are like, where did that come from? Double check and make sure it wasn't given to you and you missed it. That happens to me all the time. I think probably when I was making my key, I was sitting here asking myself, where did that come from? And then I realized it was given to me. All right, step 4. It says MN equals KL. All right, well, I know that JK equals KL, and I know that JK equals MN. So I'm allowed to say that KL equals MN. And then LM equals MN, that's the same thing. So the only thing that changed from step 2 to step 4 was I replaced the JK with an MN. So that's substitution. All right, nice. Step 5 says LM is equal to KL. All right, well, I know that MN here and here, and it's equal to LM, and it's also equal to KL. So if MN is equal to LM, and MN is also equal to KL, then I know that KL has to equal LM. You could call that the transitive property, or you could call that substitution. Either way would be okay. Five to 6. Well, 5 says LM equals KL, and 6 says KL equals LM. Hey, those were just flip-flopped. You remember what property allows me to flip-flop what's on either side of the equal sign? You think you know it? Yeah, Ava got it. Anyone else? Thank you, Camilla. It's the symmetric property. If you weren't sure of that, make sure you go back and study the properties from last class. All right, and then the very last step, I'm going from those two segments being equal, or their lengths being equal, to the segments being congruent. That's the definition of congruence. Anytime you're flipping from an equal to a congruence or the other way around, that's the definition of your congruence. That was 4. All right, let's look at another proof. All right, now before we do that, I want to give you your attendance word. Your attendance word today is given. Given. Write that down or go do the attendance quiz right now in a separate tab. Given. Once you have that, give me a check so I know that you're ready to move on. The attendance word is given, which sounds kind of punny, right? I am giving you the word. It has been given. All right. Once you have that written down, please give me a check so I know that you are there and ready to move on. Check. Okay, that works. You should be able to see the check on your screen there. 8 people there. I see. You should see the poll on your screen. Click check, and we're going to move on. Okay. All right, so let's look at this proof. I don't see any vocabulary words up there, but I do see some segments that are broken into pieces. Pretty good chance I'm going to have to use segment addition on this one. The given says that xy is congruent to uv and yz is congruent to tu. Whoa. Okay, that's given, and I'm going to mark that in the picture. xy congruent to uv, yz congruent to tu. Lovely. And then it says xy equals uv and yz equals tu. The only difference between step 1 and step 2 is instead of segment symbols and congruence, I have lengths and equals. So that's the definition of congruence. Now step 3 says xy plus yz equals xz. Well, here's xy and here's yz. And if I put those together, I get that whole segment xz. Oh, that's segment addition. Segment addition says when you have one small segment, you add it to another small segment, you get the longer segment. And that would work even if I looked at the second part of that. Tu plus uv equals that whole segment tv. Now I've got a big mess here. Hold on. All right. These are equal and these are equal. Now step 4 says uv plus yz equals xz. Well, these look the same and these look the same. X, Y, and uv. Do we know how they relate? Oh yeah, right here. We already know that they're equal. So I can take what x, y equals and replace it. And when I do that, that's called substitution. And the same thing happened here. See, TV was the same and UV was the same. So TU and YZ, well, I know that they're congruent. So I took what TU equaled and I replaced it with the YZ. So that was substitution. Okay. And now let's see. It says XZ equals TV. Well, let's see here. XZ is equal to XY plus YZ, and TV is equal to other way around. UV and TU are here. Yeah, Alexis, I might not have time today. Last class took me right up to the very end here. But we'll see. I'll try. Here it is. UV and XY, or YZ. Here it is. UV and YZ. There we go. Notice that they're both UV plus YZ, right? Since they're both UV plus YZ, that means that XZ and TV have to be the same. There it is. So we could say substitution again, or you could say transitive property, either one. I'm going to write substitution. And then if I know that the measures are the same, then of course the segments are congruent. Definition of congruence again. Sometimes it takes a little searching to figure out, where did this come from? How did they know that? And so a lot of the times, like you notice we use substitution a lot. That's a good place to start if you're stuck. So figure out, what could they have used substitution on maybe? It's not always going to answer the question, but it's a good place to start. All right. Number 6. All right, I don't see any vocabulary words in the given there, but I do see some segments that are broken into pieces. So it's possible I'm going to have to use segment addition. It says that YW is congruent to YZ and XY is congruent to VY. So I mark that in my picture and I write given here. Step 2 says, well, if those pieces are congruent, then their measures are equal. That's exactly what it means to be congruent. So that's the definition of congruence. Step 3. I see some plus signs, and I knew I might need segment addition. Let's see if this is segment addition. So here's XY, here's YZ. When I add them together, I get the segment XZ. That's exactly what that is. So I'm going to write segment addition. Step 4 says VY plus YW equals VW. Oh no, that was step 5. VY plus. All right, well, I just gave away step 5. So let's figure out what could have happened here in step 4. VY plus YW equals XZ. Well, these are the same. YZ and YW. Oh, those are equal. That was substitution. XY and VY. Oh, those are equal. So that was substitution again. So we took what XY equaled and replaced it, took what YZ equaled and replaced it, and kept the XZ the same. And VY plus YW, when I add that together, I get the big segment, that's segment addition. So that brings me to step 6. XZ. Highlighter. There we go. XZ and VW. Well, let's see. Get rid of this stuff. Here's VW, here's XZ. Well, XZ is equal to VY plus YW. VW is also equal to VY plus YW. Hey, those are the same in red. So that means what's in green has to be equal also. You could call that substitution, or you could call that the transitive property. Both would be right. I'm going to call it transitive property. And if I know that the measures are equal, then the segments have to be congruent. And that's the definition of congruence again. All right, so that was a lot of segment proofs. And when you see segments, there's a good chance you're going to need segment addition. The next example, we're not looking at segments anymore, but we're looking at angles. So here's my next tip or trick for writing proofs with angles. Okay, just like when you saw segments in pieces, if you see an angle broken into pieces or parts, then what do you think we're going to have to use? There's a good chance that we're going to need angle addition. And we learned angle addition back in Unit 1. But if you see an angle that's broken into smaller parts, there's a really good chance that we're going to need angle addition. It doesn't mean that we have to. We might not use it, but there's a really good chance that we would too. And again, I see some vocabulary words over here. I see right angle, I see complementary, so we're probably going to need their definitions. Step 1 says that the measure of angle PQR is a right, or that angle PQR is a right angle. That was my given. Well, what does it mean to be a right angle? If I told you it's a right angle, what do you know about it? You're welcome to share with that in the chat. What do you think? Yeah, thank you for participating. It means it's 90 degrees. That's what it means to be right angle. And if we're using what something means, we're using its definition. So this will say the definition of right angle. Yay, thank you those that participated. I'm seeing people that weren't participating before. I do want to warn some of you that if you are logged in under your learning coach's name, that is definitely going to mess up the attendance that I take. So I'll look for you, but make sure you're logging in under your student account next time. Yeah, that's okay. I still like you. It's all right. All right, step 3. It says the measure of angle PQS plus the measure of angle SQR is equal to the measure of angle PQR. Dylan, you got it. You're right. Angle PQS is this little dude up here. And SQR is this little angle here. And when I put them together, it says when I add them together, I get angle PQR. That's the big angle. Well, little angle plus little angle equals big angle. That is angle addition. Okay, from step 3 to step 4, I see PQS and SQR. So what does that tell us about this? Well, oh, right, PQR equals 90. So I took what PQR equaled and I replaced it. So I used substitution. Yay, I like that you're using exclamation points and all excited about it. Yay, substitution. Okay, well, what does complementary mean? Complementary means when I add them together, I get 90. And that's exactly what we did in step 4. When you add those two angles together, you get 90, which means they have to be complementary. If that's what it means, that's a definition. So this is the definition of complementary. Wow, there's a fat pen. There we go. Now we can read it. Definition of complementary. Lovely. All right. Let's look at another example with some angles. It says angle 2 is congruent to angle 3. And it says angle 1 and angle 2 form a linear pair. Probably going to need definition of linear pair somewhere. We're probably going to need definition of supplementary somewhere too. All right, step 1 says angle 2 is congruent to angle 3. Right there it is in my given, so that's given. Now notice it only said angle 2 is congruent to angle 3. There's another given here. Angle 1 and angle 2 form a linear pair. I'm going to go find that in my proof and just write that as given right away. So when I get to it, I don't get confused and wonder where it came from. All right, step 2 says the measure of angle 2 equals the measure of angle 3. So just like with our segments, when we went from a segment being congruent to segment to its length equaling its length, it's going to work the same way with angles. If an angle is congruent to an angle, then its measures will be congruent. So this is still the definition of congruence. It's just with angles instead of segments. All right, so now it says the angle 1 and angle 2 are supplementary. All right, what does it mean to be a linear pair? Two things have to be true for two angles to be a linear pair. Okay, so if you don't remember these, you're going to want to go back and look at the definition of linear pair because we're going to use it all year long. A linear pair, yay, Andrew, that's perfect. That's exactly what I was looking for. A linear pair has to be two angles that are adjacent, which means they share a side, and they have to be supplementary, where they have to add up to 180 degrees. Okay, so for a linear pair, you have to have adjacent angles and supplementary. They have to be adjacent and supplementary at the same time. Supplementary means they add to 180. So if I know that angle 1 and angle 2 form a linear pair, then they have to be supplementary because that's the definition of a linear pair. And then the next step here says, well, when you add them together, you get 180. Well, that's because that's what supplementary means. So this now is the definition of supplementary. All right, now from 5 to 6, it says the measure of angle 1, I got 180s, but 2 and 3 are what's different. Oh, but all the way back to the beginning, I know that 2 is congruent to 3. So I can take what angle 2 is and replace it. And when I do that, that's substitution. Okay, well, if I can add angle 1 and angle 3 to get 180, that means they are supplementary. So this is the definition of supplementary. Lilibeth, you should have 2 attempts on an exit ticket. Is there one that's giving you a hard time? Send me an email. Yeah. All right, that was a second example with some angles. Let's look at another example with some angles. All right, in number 3, it says, given that angle 1 and angle 2 form a right angle, and the measure of angle 1 plus the measure of angle 3 equals 90. Probably going to need the definition of a right angle. Okay, so of course, step 1 there is some given information, but it's only the first part of the given. So I'm going to go find the second part, angle 1 plus angle 3 equals 90. Here it is. Put that as a given also. All right, so if angle 1 and angle 2 form a right angle, that means together they make that right angle, which means they're complementary. Complementary means two angles that sum to 90. So this is going to be the definition of complementary. If I tell you that two angles make a right angle together, then you know that they are complementary because you know the definition of complementary. We know that step 3 is given. And then it says angle 1 and angle 3 are complementary. Okay. 1 and 3. Well, let's see. Oh, right here. Silly me. Okay, so if I can add angle 1 and angle 3 together to get 90, that means they're complementary, right? Because complementary means adding to 90. So angle 1 and angle 3 adding to 90, that means they're complementary. So we're using the definition of complementary again. You can use a reason as many times as you need to. Okay, so now angle 2 is congruent to angle 3. Angle 2 is congruent to angle 3. I want to introduce you to a new theorem that we haven't really heard yet, but it's going to be one that's going to kind of pop up here and there. It's called the congruent complements theorem. And what it means, or what it says, is if two angles are complements to this same angle, then they are congruent. So for example, if I told you that angle 1 and angle 2 are complements, complements means they are complementary. And then I told you that angle 1 and angle 3 are complements. What could you tell me about angle 2 and angle 3? What do you think? If I know that, yeah, they equal each other, right? Because here's the ones, those are the same, and those are the 90s, those are the same. So these two would have to be the same for this to be true. So angle 1 is a complement to angle 2, and angle 1 is a complement to angle 3. So that means that angle 2 and angle 3 have to be equal. So if two angles, that's these guys, are complements to the same angle, then they are congruent. So that's the congruent complements theorem. You might not have known that before class started, but hopefully you know it now. Maybe put a little star next to it. There's another theorem that will kind of infrequently pop up, but you should know it, and it's called the congruent supplements theorem. It means the same thing, only instead of being complementary, they're supplementary. Congruent supplements theorem. So the congruent supplements theorem says if two angles are supplementary to the same angle, then they are congruent. So let's say if I had angle, I'll call them letters, angle A plus angle B equals 180. And then I said that angle A plus angle C equals 180. This theorem is going to tell me that angle B has to be congruent to angle C. Okay, because A's are the same and the 180s are the same, so these would have to be the same also, or equal. Okay, so congruent complements theorem, congruent supplements theorem. Maybe put a little star next to those on your notes. All right, number 4. Number 4, I see the word bisects, so I'm going to have to use a definition of bisect. Let's see, it says BE bisects angle ABD. So I'm going to find angle ABD. Here it is. And it says that BD bisects it. So this angle has to be congruent to that one because that's what bisects means. So in my proof, this, of course, first step is given. And I was allowed to label angle ABE and EBD as congruent because that's what bisect means. So this is the definition of bisects. If you wrote definition of bisects, I'm perfectly okay with that. Know that on an assessment, it's probably going to say definition of angle bisector. Hopefully your definition of bisects and definition of angle bisector will look similar enough to you that you would pick it. Or you can just write definition of angle bisector. All right, then it says BD bisects angle EBC. Oh, that's given. So here's BD, here's angle EBC. BD is cutting it in half, so these two pieces are congruent. Oh, these two small angles, EBD, DBC being equal, that's the definition of an angle bisector again. And then the last one says angle ABE is congruent to angle DBC. Well, let's see later. If we know that ABE is congruent to EBD, and I know that EBD is congruent to DBC, then the transitive property will tell me that angle ABD is congruent to DBC. Right? I could say if blue equals green and green equals red, then blue equals red. So this is our transitive property. If you were to say substitution, I don't think I could argue with that. All right, The chat box is kind of quiet. If you have questions, just make sure you're popping them in there. Otherwise, I'm going to keep trucking along. Did I skip one? My next class connect is at 1 o'clock. All right, let's look at number 5. Number 5, it says angle RSU is congruent to VST. I'm going to mark that in the picture. Angle RSU is congruent to angle VST. All right, that's given. Well, if the angles are congruent, then the measures are the same. So that's the definition of congruence. All right. Oh, I see some angles with some plus signs, and I do see some angles being broken into parts. I bet we're going to have to use angle addition. Let's look at it. RSU is here. Ooh, let me try that again. There it is. And USV is here, and it says when you add those together, you get angle RSV. Oh, yep, that's the big angle. So this is angle addition. I can spell. Step 4 says angle VST plus angle USV equals angle UST. So I wonder if that's angle addition too. Let's check. VST is here. USV is here. And it says when you put those together, you get angle UST. UST. Yep, that's angle addition again. Okay, now step 5. Step 5 looks an awful lot like step 4. Here's angle UST, USV. The only thing that's different here is these two angles. Oh, but we know that angle VST equals RSU. That's substitution. If you're taking what the angle is equal to and replacing it, that's substitution. All right, let's get rid of this mess. Okay, now in step 6, it says the measure of angle RSV is equal to the measure of angle UST. Okay, well, RSV is RSU plus USV. And UST is also RSU plus USV. See, those are the same? If those are the same, that means that these guys have to be the same. That's exactly what it's saying here in step 6. So I'm going to call this the transitive property, but you could also call it substitution, and that would be okay. Yeah, and then Dylan's one step ahead of me there. He's right. Going from the measures being equal to the angles being congruent, that's just the definition of congruence. Good job. Okay. I'm going to do one more. We've got time for it. Here it is. Okay. In the given, I see the words complementary. So I'm probably going to have to use the definition of complementary. And here's a new trick for you. Anytime you see lines crossing, there's a really good chance that you're going to need vertical angle theorem. Anytime you see two lines crossing each other, there's a super good chance that you're going to need vertical angles, because remember learning vertical angles in Unit 1? Vertical angles say that if you have two lines crossing each other, then the angles opposite will be congruent, no matter what. All right. Now in this proof, they gave us two givens and they gave them their own lines. So each one of these is given, and that's okay. what does it mean to be complementary? Complementary means they add to 90. So if I tell you angle 1 and angle 2 are complementary, you know that they add up to 90. So this is the definition of complementary. Same thing with 3 and 4. If I tell you angle 3 and 4 are complementary, well, then you know that they add up to 90. So that's the definition of complementary again. Right, so then it says angle 2 is congruent to angle 3. Why would angle 2 be congruent to angle 3? If you can't get it from the stuff you already have written, maybe look in the picture. Oh, look, angle 2 and 3 are vertical angles. Dun-dun. So we're going to write vertical angles. It might also be called the vertical angles theorem. Or it might say vertical angles are congruent. Depends on who wrote the problem you're looking at. But if you see the word vertical angles, you're good. Like, I don't like to make you memorize the names of the theorems. I prefer you know what they mean. So I'm not going to make you write vertical angles theorem. Okay? But I expect you to know that vertical angles are congruent. So I would love it if you wrote vertical angles are congruent. On an SOL, it might say vertical angles theorem, or on an assessment made by K-12, it might say that. But as long as you can pick vertical angles, you're good to go. All right, if those angles are congruent, then their measures are the same. So that's the definition of congruent. Definition of congruent. Good job, Caleb, you got it. All right, now let's look here. It says the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. See how they're both equal to 90? So I'm going to take that first 90 and replace it with what the second 90 is equal to. That's substitution. So I'm taking this 90 and replacing it with what 90 is equal to. Cool. All right. Now in step 8, these are the same, these are the same, these are the same. These are different. What could I do with an angle 2 to make it an angle 3? Oh, angle 2 equals angle 3. So that's substitution again. Okay, now here comes one that we haven't seen yet today. I saw it last class. Do you see how they both have an angle 3 on both sides? Wow. If I subtract angle 3 from both sides, then I'm going to be left with just the measure of angle 1 and the measure of angle 4. So if I subtract the same thing from both sides, that property is the subtraction property of equality because I'm using an equal sign. Good job, Camilla. Yay. And then that last one, I think we're catching on to this part. Whenever the measures are equal, then we can say the angles are congruent. That's the definition of congruence. Awesome. Hopefully going over a bunch of these helped, right? Looking at it the first time might have been scary, but hopefully going through them has helped. And even if it's still feeling challenging, at least you know where to start asking questions. If you would like more practice problems, there are practice problems in OMHS right after the exit ticket. There's practice problems there. And I also have a few resources available if you would like extra stuff. Please remember that the exit ticket is open. You'll want to do that. Anything from quiz 2-2 and before will be on quarter 1 and will close on Friday. So please make sure that you have those completed. The benchmark will open to you on Monday. Look for an email from me on how to access that. There won't be office hours next week, but if you do find yourself stuck and need some help, let me know. And if you choose to take the Unit 2 test next week, that'd be a great idea. Just make sure that you give yourself the 3 hours to do it, because once you open it, time starts ticking, and I'm not resetting tests anymore. So if you open the test, you got to finish it in the 3 hours. It was great seeing everybody. I hope you have a great day, and I will see you not next week, but the week after.